Good morning, everyone. Hopefully you all had a great weekend. Haven't seen you guys for a few days. Didn't see you on Friday, didn't see you yesterday. So it's been 4 days, which is a long time. If you don't mind, give me a green check in chat, and I'll just make sure you're all with me. You can hear me. Again, same drill as always. We have the live feed going and then the chat going separately. So looks like most people are throwing in some check marks there, which is good. While you guys are doing that, I had a few people message me some questions they wanted me to go through this morning on practice. So I would be happy to field any questions. So if you want to throw those into chat right now, I can go over a few questions from last day's assignment. We're talking about cones and pyramids. So anything that you had questions about there, I can go through. Ava, I've circled your questions, so I'll make sure to get to those. And if anybody else wants to throw some in, we should be good. There's a few people without green check marks, maybe just slow internet connections, or maybe it's just early on Tuesday morning and you're just a little bit sleepy. There we go. A few more coming in. Perfect. While everyone kind of checks in there, I just want to kind of give a quick recap, a little bit of where we are, where we're going, and kind of what the next few days are going to look like. So this is the course here behind me. I'm just going to scroll down to Unit 2. So we've done Lesson 3, Lesson 4. You can see there's Lesson 5 and 6 are the last 2 lessons that we have to do. I'm going to hope to get through 5 today. It's pretty straightforward. It's surface area of cones and things like that, or sorry, not cones, spheres, surface area and volume spheres. And then the last section's kind of sums everything up, and it's going to be just problems. So a couple questions coming in here in general, throw them up on the screen here. Lateral surface area, for sure, I can go over that. That comes up in a couple of the questions that I'm going to go through, Abby. And then Isabel's asking about what are we doing today? So we're on Lesson 5 today. So if you want to print off Lesson 5, that'd be great. And then I'm going to go through a little bit of Lesson 4 before I get going on 5. So hopefully that kind of gets you to where you need to be. I have this Unit 2 quiz number 3. I said attempt before today, and probably about 5 or 6 of you had a chance to go in and have a look at that, which is great. That's all I wanted. I'm going to go through a bunch of this stuff in class today, and I'm going to expect that you guys do that quiz today after we're done at some point before tomorrow's class. You can see we have 2 lessons left, and then we are going to be into our first sort of unit test. And the way this is going to work is a few people have been messaging me, asking me about the unit learning guide up at the top here. So I'll just go to the top of the unit here. A little bit too far. The Unit 2 learning guide review for the test, please print. And this is going to act as a bit of a review for the test. And if you haven't had a chance to print that out and start looking at it, it'd be good to start that today. We have 3 classes this week and 2 more lessons to go through. So I'm going to, you guys have a bit of a long weekend as well. Friday is a Pro D, and then Monday is a holiday for Thanksgivings. So I'm hoping you guys will have a chance to write the test between Thursday and then when I see you next Tuesday again. So it gives you a lot of time to get through that test. The way that's going to kind of work is once you're done your learning guide, you're going to submit it to me. I'm going to go through it and make sure that everything kind of looks good and you've done things correctly. And then once I've had a chance to go through that, I'm going to send you guys a code which allows you to access the test. So without the code, you can't get into the test. So basically, kind of way you might want to think about it is the learning guide is a chance for you to prove that you're ready to write the test. If you go through that learning guide and there's a lot of errors and mistakes, I'm not talking like 1 or 2, I'm talking, like 5, 6, 7, 8 errors or mistakes, then I'm gonna get back to you and I'll provide you some, help, and we can find a time to meet and go over some things. Make sure you're ready for the test. I don't want to just throw you into the test if you're not ready. So The learning guide is going to act like a bit of a review. It's going to let me kind of know where you're at in terms of the course, and it is going to be important. And Abby just asked here in the chat, is learning guide for marks? Yeah, so the learning guide is for marks. It's not a lot, but they do count for a few each. There's one learning guide for each unit. So basically it's marked on a rubric, so it's not like I go through every single question and write answers. If you're getting them all right, what you should be, I mean, it's definitely open book. Use your notes, use your lessons, use the quizzes. You can go back and look at all your stuff and go through it. Completely open book, that's fine. And then hopefully you have a chance to ask me some questions about it and I can answer them in class. I'd be happy to go through a few of them in class as well. So yeah, all the solutions are there, but it is kind of a chance for me to see where you're at. So can we do a couple of questions if we got them wrong in the learning guide? Yeah, I mean, I'll point out which ones you got wrong. Hopefully it's not a lot because you can, look at your notes and things like that. So I want to make sure you guys kind of know where you're at for the first unit. And you're going to maybe get one or two wrong. It's not a big deal. It's just part of the process, right? So don't be afraid of getting questions wrong. If you don't understand something, that's a little bit different. But if there's like a little transcription error or something, you wrote down something wrong or things like that, these mistakes kind of happen. So learning guide will be submitted. Hopefully you can get that in for Thursday, Friday maybe. I'll have a chance to look at it over the weekend. But if you don't, I get it. I would love if everyone finished the test over the weekend, but I know that that's not going to be possible for some of us. So once you get that learning guide in, I can get back to you and then I'll give you the code for the test. That's kind of how we're going to run things. So Abby asked a few more questions. Lesson 3, practice 2C. Okay, I can do that. If I don't want to go back to lesson 3. I think Ava had a question on lesson 3 anyway, so I'm going to go back there. But I need to jump into this stuff. So the learning guide, Taylor? Sure thing. The learning guide is in the course. If you go to the very top of unit number 2, it shows you all the learning outcomes here. You guys are going to get through. And then the learning guide looks something like this. It'll show up in here. You can print it off. Basically, it's just has some definition stuff in it. Lots of questions, measurements, conversions. Basically, all these things we've done using ratios. Convert the following, SI to imperial. So we did that a while ago. And then some measurement stuff, surface area of cones. And then the last stuff will be the spheres. Get down to the very bottom. So you have some cones. Same sort of stuff. Volumes, which we've covered. And then the very end is going to be all of your sphere stuff, which we're going to go through today. It is long, so you probably want to get started on it. And then the very end is just the problems that we're going to go through next day. Is asking when do we do that. We're going to get that done hopefully for the end of the week, somewhere Thursday, Friday in there. So that's that. I have a few questions I was going to go over. Jump to practice number 3 here. I think Ava asked about this question. I forget what number it is. I just circled it. That's 2. Find the surface area, and it's 2D from lesson number 3. So I'm going to go through that. I'm just going to flip my screen around here. All right. So the question is find the surface area. This is, the shape's a little bit different than what we've normally run into because it has a triangular base instead of a square or rectangle. Bria, sure, we'll do 1E as well if you'd like. So what we need to do is we need to remember what the surface area formula is. And surface area of one of these shapes is, we're going to take the surface area of the lateral sides plus the surface area of the base. So we'll have the lateral area plus the base area. This one's a little bit different because it doesn't have a square rectangular base. But we do have some information we do know. So we have the height of this guy, and we have three faces, which are all the same. We have the base length, and we should have enough there. So the first thing it says is draw a net of the pyramid, and hopefully you recall from grade 9 drawing nets what those are all about. I'm gonna maybe just do it down below here, and then I'll so if I have a net of this guy, imagine cutting it along each of the edges. So I'm going to basically unfold it. That's kind of what we're dealing with here. And if you can imagine, I'll just maybe shade these in red so you know what I'm talking about. If all of these got folded up and then these 3 points, 1, 2, and 3, would all meet at the top, and those would form our apex. So that is essentially what we are doing while we're drawing a net. Brendan's asking if he should get started on the assignments. Maybe stick around for the lesson, and then you can go back and work on those assignments after. You might pick something up that'll help you. All right, so I need to find the lateral areas, and then I'm going to find the area of the base. So like all of these questions, I'm going to draw in this green line here, and that's going to be my slant height. So if I just took one of these triangles, so one of the faces, I know the bottom is 10, and I'm going to end up with this triangle from here down and then across there. So I need to use the information I have to figure out what that's all about. Maybe I'll draw that one too. There's a lot going on here. My red line coming down, my green line going across. So I'm trying to find the green line. Once I get that, that green line is going to tell me the height of this triangle, and I already have the base. If it's 10 centimeters across the bottom, halfway is going to be 5. So this is going to be 5. I don't know what the slant height is, but I do know the height is 8.5. So I'm going to use that information to try to figure out that green line. And the green line is the hypotenuse, so I'm just going to leave it as the C in my Pythagorean theorem. So I'm going to have 8.5 squared plus 5 squared is, I'll call it S for slant height squared. Now, I haven't done these ahead of time, so I'm going to have to plug away just like you. 8.5 squared is going to give me 72.25, and then 5 squared is 25, so I'm going to add 25 to that. I get 97.25 is S squared, and then in order to get just the slant, I'm going to take the square root of that. And I get 9.86. All right, so now I have the slant height of that. From that, I can multiply that, or add that into my diagram here first. Let's do that. So this is 9.86. Now, I have 3 of these faces. Just put that in a box, you know what I'm talking about. I have 3. So I'm going to find the area of that. So the area of the triangle is going to be base times height divided by 2. I know the base is 10. The height is 9.86. I'm going to divide that by 2. So I get 49.3. Now that gives me one face, and I have 3 faces. So I'm going to have to multiply that by 3. So the surface area of my lateral area is going to be 147.9. 0.9 centimeters squared. So I know that it's going to go back up into the question into the lateral area. And then I need to find the base area. Now I have almost completely run out of room, so I'm going to just go over here. If this triangle is my base, I have 10 by 10 by 10. It says it's an equilateral triangle for the base. So what do I need to do? Anytime I'm trying to find the area of a triangle, it's going to be base times height. But I don't know what the height is, so I'm going to have to find that height. And how am I going to do that? You guessed it, Pythagorean theorem. If I divide this base in half, I'm going to have 5 and 5. There to there and there. So here we go again. A squared plus b squared is c squared. In this case, 10 is the longest, so I'm going to put it in for c. So I'm going to get 10 squared. The base is 5 squared. And then I don't know what my height is, so I'll call that h squared. So I'm going to get 25 here. I'm going to subtract that 25 from both sides. And I'm going to end up with h squared is equal to 100 minus 25 is 75. And you take the square root of both sides. I don't know what the square root of 75 is, but my calculator does. I get 8.66. All right, so now I have the height. Now I have to find the area of the base. I'm going to have base times height over 2. And in this case, my base is 10. My height, I just calculated to be 8.66, all divided by 2. Oops. 86.6 divided by 2, it's going to give me 43.3. Now that was the area of the base. So I'm going to take that now and plug it into there. I might just squeeze it in up here, just enough room. The lateral area I had as 147.9, and the base area I just found was 43.3. So I get 191.2 for my surface area. So my total answer is 186.4. Hopefully I didn't make any mistakes. So I don't know where I'd go find those. I'm just going to take a quick look at the answers. 2D. 186.4. So obviously I did make a mistake somewhere. But I'm not going to be able to figure it out unless I do it all over again. And Taylor, you got it right, so you're a step ahead of me. Anybody see any obvious places where I would have made a mistake? The height's 8.5, not 8.66. Where did I... Here for this height. Oh, maybe that's a different triangle we're thinking of. I'll tell you what, guys. Could the answers be wrong? Yeah, they have been wrong before. If Taylor got 186.4 and that's the right answer, then I'm going to go ahead and go with that's probably right. You got 8.66 for the height here. Yeah, I got 8.66 as well. So unless 3 or 4 people got the same answer as me, I'm going to go ahead and say that the answer in the solutions is likely the correct one. But if anybody else got the same solution as me, then maybe mine's looking more correct. So I'm just going to leave it there. I'm going to go find the solution after class, and I'll post it up as a video perhaps. And that way we can make sure we're all on the right track with that question, because it was a lot of steps and a lot of places to go wrong. So if you got 186.4, like the solution said, that's great. If you got the same answer as me, which nobody's writing in, so I have a feeling I did something wrong, I'll have to go back and relook at it with a little bit more time. So that was lesson number 3. I do want to get to some of the lesson 4 stuff. So that was the cones and the surface area. So a few that people had posted in were number 1C, so I'll do that one for sure. There was a couple more, 2B, and then number 4, and then a few of these word problems. So I'll definitely do a couple of these. How about 1C to start? The volume of the block. So when we find the volume of these sorts of shapes, it's going to be the area of the base times the height. So when we find, when we think about these shapes, what sort of base are we dealing with? So in this case, the base isn't this square on the bottom here. I guess it's a rectangle. That's not the base. Even though that's where it's sitting, we don't want to think of that as the base. We always want to think of the shape that we're dealing with as the base. So in this case, the shape we're dealing with is a triangular prism. So even though it's facing us, we want to think of that as the base. And the easiest way to kind of go about this is, if you think about just having that shape, that triangle, and then kind of stretching it out. That's how we always want to figure out which is the base. Because we always want to find the area of the base and then multiply it by the height. So if I just for a second look at maybe like this guy here, same thing. We want to use this triangle as the base, and then this 30 feet is going to be the height. So that's kind of the trick to these questions. They're not always going to put them with the base facing down. So you need to kind of just understand that we're going to have a triangular prism or rectangular prism. The base is going to be the triangle. It could be a right triangle. It could be a triangle like this one here. But for this question, we're going to deal with this right triangular face as being the base. So we're finding the volume. The volume formula is going to be the area of the base multiplied by the height. Ava says it's 1E, not C. Did somebody else ask for 1C? No. All right, I'll just mosey on down to E then. Calculate the volume of the soil in centimeters that could fit inside this planter box in the shape of right trapezoidal prism. Okay, sorry about that. Again, the base is going to be this trapezoidal prism, and then we're going to have the height. In this case, the height is going to be 42. Even though the base is facing us, you want to think of the shape and then just extending it. So the base is always going to have the same shape on opposite sides of whatever object we're dealing with. So there's no formula on our formula sheet for trapezoidal shapes, so we're just going to have to use some common sense and think about what this shape really looks like. If I draw some dotted lines up here, what I really end up with is, this is going to be 22 centimeters. I end up with a couple triangles, and I end up with a rectangle. So I know that the distance all the way across is 30. I've used 22 of it in this middle portion here. So what's left over? So 30 minus 22 is 8. So in order to have 8, I'm going to have this little piece is 4, this little piece is 4, and that is going to give me the information I need to calculate the volume of this thing. So again, volume is going to be area of the base times the height. And in this case, the area of the base is going to be my trapezoid. Now, I'm sure we could find the area of a trapezoid. I don't know what it is. Oops. I don't know what it is, so I'm just going to have to do it kind of manually, we'll say. So what I'm going to do first is find the area of this triangle, and then that area is going to be the same as the area of this triangle. And from that, I can find the area of the rectangle, and then I can add those together and I have the area of the base. So if I maybe just redraw the triangle over here, I'm going to draw it this way, which may be not a good idea. I'll draw it this way. So I have this, the 28 is over here. I have a 4. In order to find the area of a triangle, I have to do base times height divided by 2, but I don't know the height. So we're back to this base times height problem where we have to calculate it using the Pythagorean theorem. So I'm going to go a squared plus b squared is c squared. In this case, my a is going to be, let's make it h. 4 squared is 28 squared. Save a little bit of time, I'm just going to plug this into my calculator. 28 squared minus 16 and the square root. So the height is going to be 27.7. Now to find the area of this, I'm going to go base, which is 4, times the height, which I just found to be 27.7, divided by 2. So I get 55.43. All right, so 55.43 centimeters squared is going to be the area of just one of these triangles. How many triangles do I have? Well, I have 2, one on either side. So I'm going to multiply by 2, and I'm going to get 110.85. For my 2 triangles. Now we want to think about this blue rectangle in the middle here. I know that it is 22 centimeters across. Maybe I'll just draw it here. And I need to know, do I know how high it is? Do I know how long this side is? Yeah, I just calculated that. I found out that h from over here was 27.7. So what I can do is just find the area of that is going to be length times width, which is the 27.7 times 22. So I get 609.4. All right, so now I have enough information to find the area of the base. I know the two triangles and the rectangle. If I add those two things together, will give me the area of the base. So I will just go down below here. Area of base is going to be the 110.85 plus the 609.4. $720.25. So that gives me my area of my base. The other thing I need to know is the height, and in this case, the height from here to here is going to be 42. So what I can do is, I'm just going to take this number, run it back up to the top here. So I have 720.25. The height of my shape, even though it's kind of looks more like the width than the height, is going to be 42. I end up with 30,250.5. And that is centimeters cubed because it is a volume. So hopefully that helps more than hurts. Again, the trick with these questions is to have the right base. And the base is always going to be the shape that's kind of been stretched out. So you have to have the same faces on either end. It doesn't necessarily, you can always just turn it, but if you have a trapezoid on this end and a trapezoid on this end, if you can imagine us just cutting it down the middle and stretching it out, so the height is going to be the distance from the trapezoid to the trapezoid. So it always has to be the same shape on either side for our base. You don't want to use, like in this diagram, you never want to use this as the base because this shape on the bottom, this rectangle, isn't the same as the rectangle on the top. They're completely different sizes. So that would be a problem. So that's kind of the key to these. Maybe have time for, well, I probably don't have time for one more, but I can find time for one more. Which other ones did we have there, Ava? There was a few of these word problems. So 2B, 4, and I think 6 and 8 you may have mentioned. Maybe we can pick one of those. Did anybody have troubles with 6, 8, or 4? 6, 8, or 4? Could go through those, just one of them, and then I can move on. Abby's writing something. What is Abby saying? No? Maybe I'll just pick one then. 4 is calculate the volume of semi-cylindrical trough. Lesson 3, 2C. Calculate the volume of the right cone. Okay. We have too many questions and not enough time. So let's have a vote. Who wants 2C and who wants 4, 6, or 8? Just type one in. Type one into chat. I'd be happy to do one. The air thing, that's probably just, they use just a test bank to plug these things in. So it's likely that it just was a problem with the question or something. It doesn't mean anything to you guys. They just kind of select a bunch out of a bank and put them in there. Alex said 8. I'm pretty sure Ava said 8 as well. Maybe I'll do 8, although I don't have any room. The inside radius of plastic pipe is 40, and the outside is 44. What is the maximum volume water that could flow through 100 meters of the pipe, and how much material was used to make 12-meter length of pipe? All right. So the inside radius, draw it a bit bigger. Inside radius is 44, and the outside radius is, got that backwards. All right, it kind of looks like a clock now. That's 40, that's 44. The idea here is you're going to have to do sort of two volume calculations. You're going to have to subtract the inside from the outside. If you can imagine, this is a big, long pipe, so a 3D shape. It's going to extend. The first part of the question says 100 meters of the pipe. So the water volume is going to be what's going to be able to fill up the inside of this pipe. So for the first part of the question, we don't even really care that that the outer diameter, outer radius is 44, because it's not important to the question. We just want to know how much stuff goes on the inside. So if we can find the volume of the inside, assuming this is 100 meters long, that's going to be good enough. So to do the area of a cylinder, or sorry, we're looking at volume of a cylinder, because this is in fact a cylinder. We have volume as area of the base times the height. See this as being a bit of a trend. And what is the area of the base? Well, I go to my formula sheet, and the area of the base is essentially a circle, and that is going to be pi times r squared, and then I'm going to multiply it by the height. There's one sort of trick to this question, and that is that the radius is given in millimeters, and the length is given, or the height is given in meters. So we have to do a bit of a conversion at some point here. Let's just stick with finding the area of the base here first, times the height. So I'm going to have pi. The radius of the inside is 40 millimeters. I'm going to just write in units. I know I don't always, but just because this one's tricky. I have 100 meters, and if we think about it, 100 meters, I can convert to centimeters first, I guess. So there's 100 centimeters in a meter, and I want to get rid of meters. Get rid of it. Centimeters on the bottom, millimeters. In 1 centimeter, there's 10 millimeters. So in order to do the conversion from meters into millimeters, I'm going to multiply 100 by 10. And we're just moving zeros over. So 100 times 100 is going to give me 2 more zeros and then another 0. So my pipe is 100,000 millimeters long. So pi times 40 times 100,000. It's going to be a big number because it's in millimeters. Maximum volume. I assume the volume for 8 is going to be in meters. Let's do the opposite then, because the answer is in meters. It doesn't tell us specifically in the question which way to do it, but the answer is in meters. So I'm going to leave that as meters, and I can convert this millimeters into meters. So I'm going to go millimeters. There are 10 millimeters in 1 centimeter, and 1 meter is 100 centimeters. So I'm going to take the 40 divided by 10 divided by 100. And again, we're just moving decimals over. So I get 0.04 meters for 40 millimeters. So I'm going to put that in, I'm going to square it. I'm going to multiply it by pi. And then I'm going to multiply it by 100. And I get 0.50265 meters cubed for the water that would be able to go through there. So that was the first part of the question. The second part of the question asks how much material was used to make a 12-meter length of pipe. So if we look at our picture, the material, it's talking about the physical pipe. So if I just colored this in, it's trying to figure out how much stuff goes into making the actual pipe. Now, the best way to do this is if we knew how much the total volume of this thing was, the outside diameter, we could figure out as if it was a solid piece of pipe, 12 meters long. And then once we knew the solid piece of pipe, we could figure out the inside volume and we could just subtract it. So I'm going to find some space down below. So I'm going to redraw my picture here. I'm going to just draw it as two different pictures. So I had the first one is 40, and then I have the second one is 44. Now if I find the volume of this bigger guy, and I subtract the volume, kind of wrote that backwards, but I subtract the volume of this guy, what's going to leave me with is I have the big guy, and then the little guy is gone out of the middle, so what's left is going to be the actual pipe. And in this case, the pipe is going to be 12 meters long. I believe that's what the question said. How much material is used to make a 12-meter length of pipe? Yes. All right, so the volume is going to be pi r squared times h. So I'm going to have volume for the inside, I'll call it volume I. I'm going to have volume O for volume of outside, pi r squared h. In this case, the radius, I'll do this all in meters because the length is given in meters, so is 0.04 squared times 12. You can do the exact same thing here, except I don't have 0.04, I have 0.044 because it's 44 long times 12. And I'm going to calculate each of those separately. So 0.04 squared times pi times 12 is going to give me 0.0603 meters cubed. And I'm going to do the same thing again, except I'm going to go 0.44 squared, 0.044 times pi times 12, you get 0.2985 meters cubed. And then I'm just going to subtract the smaller from the larger. So to find the amount of material, I'm going to take the 0.729, keep on skipping a zero, 0.072985. I'm going to subtract the 0.0603. And I get 0.0126 meters cubed. All right, so that question, obviously it's the last one, which kind of indicates that it's the most difficult. That's going to be more of the type of things we're going to see in the last lesson of the unit instead of this sort of section. So you can see with these problems, there's lots of stuff going on. And the best thing is for you to just kind of take a deep breath and kind of think about what's happening. Because a lot of times relying on formulas and things like that to try to make these questions work will only get you so far. So you just got to kind of think about what's going on. And as you do more and more of them, you'll kind of see that there are always sorts of similar problems that you're going to run into. So what's the answer? Sorry, I'll just scroll down a little bit. 0.0126 meters cubed was the answer. So we take the outside and we subtract the inside. And Taylor, if you get 0.0125 and you're off by, like a very minuscule amount, don't worry about it. You're close enough. Again, it's rounding. You want to keep as many digits as you can. And as you guys get more and more used to using your calculators and more used to doing these questions, you'll find that it's easier to carry all these digits as you're going through these things. So that's that. Now, Ava, I am going to apologize right now. I really do need to get on to the next lesson, but I will be glad to meet you later if you would like to go through a few of those other problems, because I know you asked about a few other ones. So we can arrange the time to meet, and if anybody else has other questions from this, because this stuff is tricky, guys. This is like about as hard as this unit gets, these surface area questions. So if you have other questions, let me know. Hopefully I can maybe, we can go through it even later, right? I'll have some time tomorrow in class and on Thursday's class, and I'll be able to go through more of them. But I just want to kind of keep moving so we don't kind of get bogged down in this stuff, because it can get tricky. The next lesson is lesson 5. And this one's on surface area and volume of spheres. And I'm going to say this is maybe a little bit easier than what we've been dealing with. And usually students feel that way as well. So here we go. I'm going to kind of cruise through this a little bit. Just want to get done in the next 20 or so minutes. A sphere is the set of points in space at the same distance from a fixed point, which is the center, a line segment that joins the center to any point on the sphere. You guys remember this terminology from grade 9, I bet. So the radius is from the center to any point on the outside. Yes, Abby, Ava, we will arrange some time to go through some questions. And Taylor's asking about where we are. Yes, I just want to go through lesson 5 real quick so we can just keep rolling. A line segment that joins 2 points on the sphere. So it doesn't matter because the sphere is kind of uniform everywhere. A line that joins either side is going to be called the diameter. As long as it goes through the center. If it doesn't go through the center, it's called chord, which we'll eventually talk about. So the two things we're concerned with, as you probably have guessed, surface area is the total area on the surface, where volume is how much space it occupies. You guys are on it. You guys know this stuff. We don't have the constructor understanding, but a couple important things. Area of a circle is going to be pi r squared, and we don't have to worry about that. So area of the circle given on your formula sheet. Surface area of a sphere, again, we don't have to memorize these things. They're given on our formula sheet. Surface area is going to be 4 pi r squared, and the volume is going to be 4/3, or 4 over 3 pi r cubed. And the sphere stuff on our data booklet, let's see if I can find it. It's on the back page. It's the second one down. It has the surface area column, then it has the volume column. So these units are all given to us, formulas are all given to us, so we should be able to make sure we use this. We can use the formula for surface area of a sphere, develop formula of volume of a sphere. There we go. So the radius of baseball is 1.5 inches. I don't know why my images don't load. Hopefully you guys have that wonderful picture of a baseball on your page. It asks us to find the surface area of a baseball to the nearest square inch.